Alright guys, in this video this is your FRQ notes for the week, and you're going to watch this first and then you're going to try some practice problems that are kind of like it on a worksheet that we'll be doing for this weekend. These types of questions will pop up on your quiz next week, so not all of them, just maybe one or two of them. But this is just to kind of get you ready to see the types of questions that are asked on the AP exam, and these are things that are related to the topics that we are currently learning. So at the top I put what year this FRQ was given. This was an FRQ given to calculus students in 2014. It's question number 1. And I'll also tell you if you can use a calculator or not for this question. And for number 1, it is a calculator-based question. So let's go ahead and get started. Like I said, every problem that I show you how to do on here, I'm giving you a worksheet with a similar problem for you to do, so that you can apply what you've learned here to another problem. So here we go. It says grass clippings are placed in a bin where they are decomposing. For t between 0 and 30, the amount of grass clippings remaining in the bin is modeled by this function here, where a of t is measured in pounds and t is measured in days. So let's go ahead and interpret this first. We have grass in a bin and it's decomposing. And t, well, this formula right here tells us how much is left in the bin based on time. And time could be anywhere from 0 to 30 days. So if you were to plug in 30, you're going to probably get a smaller number than if you plugged in 0, right? Because it's decomposing. If you plug in 30, that's telling you how much grass will be left in the bin after 30 days. If you plug in 0, that tells you how much grass will be left in the bin at the very beginning, and any other number in between will work. So this is measured in pounds, and time is measured in days. So when you're doing a lot of word problems, you want to pay attention to your units. My units are pounds and days. All right, but let's go ahead and get into the actual math part of this. This is asking me to find the average rate of change of A on the interval from 0 to 30, and they want me to indicate the units of measure. So this question on the AP exam would be worth about 2 to 3 points. They're definitely going to give you 1 point for the units, getting the units correct. And then finding the average rate would at least be 1 point. It's possible that it's 2, but it's likely to be just 1. All right, so let's go ahead and begin. So in this particular problem, as you guys remember, we want to find average rate of change here. You don't need to write this down. In fact, I would ask you not to write this part down because these letters don't actually match. But we talked about this. That's how you find the average rate of change of a function. Okay? The reason why I didn't want you to write that down is because we're not using those variables, right? We're using a of t. That's kind of like our y variable. And we're also using t, which is kind of like our x variable. Okay, so if I were to rewrite my average rate of change formula, instead of y2 minus y1 over x2 minus x1, I would have the following. I'd have time 2 minus time 1, because my input variable is t, it's not x. How do I know that? Because it's the one in parentheses here. The output variable is the function itself. So the y value for t2 would be a of t2, and the y value for t1 would be a of t1. So this is my y2 minus y1 over x2 minus x1 formula, but using the variables that they gave us, right? Now, what's this? I want to find the average rate of change, right, on this interval. So this is my t1, and this is my t2. So if I wanted to apply this, then I would write a of 30, that's my t2, minus a of 0, that's my t1, over 30 minus 0. Now, I'm going to erase this part over here, but if you want to include that, you can, but definitely what you want to have is this part here in your notes, okay? But if it's helpful to you, you can include this also, all right? So average rate of change is y2 minus y1 over x2 minus x1. In this problem, these are the variables we're using, though. We're not using x and y. And the time values that we're applying are 0 and 30. So there's that. Now, I can do the bottom pretty well. 30 minus 0 is just 30, right? And it's important to remember what these are. These are days on the bottom, right? It says t is measured in days. So these are days. So I'm gonna write days on the bottom here. Why am I doing that? Because in this problem, they want us to indicate the units of measure, okay? In other words, days and pounds. Pounds is the top. Says the A function is measured in pounds, T is measured in days. So the top is pounds, the bottom is days. So now I haven't done the top yet, so for now I'm just going to leave a blank there. But I do know that whatever I get up there is going to be pounds. So my units are going to be pounds per day. But let's go ahead and stop with that. So review, average rate of change, y2 minus y1 over x2 minus x1. That's this, though, with the variables we're using. Plugging in 30 and 0 because that's the interval we're working with. And then we have our units here. Now the question here is, and this is where the calculator is going to come in handy, is how do we get the top of this fraction? How do I find a of 30 and a of 0? Well, you could just, you could try to plug these things in by hand. Like you could plug in 30 up here like this. But this is a calculator active problem. And honestly, I would have known this is a calculator active problem simply by the fact of the way this equation looks. I mean, that's impossible to do that mentally. So there's no way that anybody's going to be able to be expected to raise 0.931 to the 30th power and multiply that by 6.687 and still have time to finish the test. That's impossible. So that's a calculator question when they give you an equation that's that funky. So instead of doing that by hand, we're going to use our calculator. So let's go ahead and I'll show you how to do that on the calculator. We're going to calculate this numerator piece here on our calculator. All right, so I'm going to turn my calculator on with this button here. Then I'm going to go to y equals to put the function into my calculator. So I'm going to push y equals. I have some functions in here from before, so I'm going to go ahead and get rid of those real quick. All right, now I'm going to put in my function. So the function for A was 6.687, parentheses, 0.931, close parentheses, to the power, that's the power button, that little arrow, to the power of, now I'm going to put x. Now I know that our problem said t, but remember how I told you that in our problem, we're using the variables a and t, but that's like y and x. So t is like our x variable, a is like our y variable, and our calculator only does y and x. So we have to do that here. So typing that into our calculator, we're going to now push second and quit. That's going to take us back to our home screen, but now my calculator has that function of a stored in there. Now what I want to show you how to do next is how do we calculate this expression here? How do I do a of 30 minus a of 0? Well, our calculator will do it for us. So here's how you do that. As you guys might recall, you don't need to press this, but as you might recall, I stored my function here under this thing called y1. So let me get out of there. I'm going to show you guys how to work with that function now that it's been stored in there. This is a key sequence. It takes a few pushes, so at first it might seem a little overwhelming, but it's something we're going to do a lot when we work with calculators, so hopefully it gets to be a little bit more familiar as time goes on. So to bring up that y1 equation, here's what we're going to do. We're going to start by pressing variables, vars right here. Then we're going to scroll over to where it says y vars. And then we're going to press 1 for function. And there's that y1 right there. That's y1. That's the letter that I stored my function under. So I'm going to push y1. Now, that's kind of, for me, that's like a. Remember on our word problem that this was a, but our calculator knows it as y1. So instead of doing a of 30 minus a of 0, I'm going to do y of 30. So I'm going to push parentheses and 30 minus, and then I get to do y1 again. So let's go through that sequence again. Vars, y vars, function, y1, and then parentheses 0. So this is like a of 30 minus a of 0. It's just that our calculator doesn't use the letter a. Instead, it's using y1. And then you're going to push enter. Okay? So rounding to the thousandths place, we're getting negative 5.904. As I told you in this class, we always round to the thousandths place. So let's go ahead and put that answer up there. Negative 5.904. Now, we can simplify this a little bit more. But before we do, let's interpret this a little bit. These numbers are days. This is the 0th day. This is the 30th day. This is how much grass is left in the bin after 30 days. This is how much grass is in the bin on the 0th day, in other words, at the beginning. So if I subtract 0 and 30, that tells me 30 days have gone by. If I subtract A of 30 and A of 0, that tells me I've decreased in the amount of grass in that bin by negative, I decreased by 5.905 pounds. How do I know I decreased? Because it's negative. It's negative. It went down. Okay? So from the first day to the 30th day, the bin lost 5.905 pounds of grass. Okay? So now we're not quite done yet because we can actually divide these. So let's go back to our calculator really quick and divide our answer by 30. So all I have to do now is I'm just going to push divided by, because the last thing that my calculator entered will naturally be the first thing that it operates with. So just push divided by. It's going to say answer, which means this, divided by 30. And then push enter. And there's my final answer. We're going to round to the thousandth place once again, and we're going to get negative 0.917. Negative 0.197. So let's go ahead and write that one down. And we're going to put the units next to it. It's pounds. Matter of fact, I think I'll just use abbreviation, pounds per day. And we are done. That's the final answer. Okay? So this FRQ, that particular question would probably be worth 2 points. You would probably get 1 point for your setup, all this stuff that I did here, and then you'd probably get 1 point for having those units. So that's probably a 2-point question. And on the AP exam, it's all or nothing. So you can't, even if you're close, it doesn't matter. You either get it completely right or completely wrong. So, if they didn't see this in some way, shape, or form, and if they didn't see this in some way, shape, or form, then you would be losing some points there. So that's how the AP exam is graded there. Now let's go ahead and take a look at another question here. Let's go ahead and take a look at Part B. Part B says, find the value of A prime 15. Using the correct units, interpret the meaning of this value in the context of the problem. All right, so first of all, I just want you guys to know this is an instantaneous rate of change, right? Now up here we found an average rate of change. The units for this problem are going to be the same as this because they're both a rate of change. So even though this isn't obvious or as obvious as Part A, the units for this problem are still going to be pounds per day. This one told us on average how much the amount of grass in the bin was decreasing per day. This one's going to tell us the instantaneous rate at which the pounds are decreasing per day at a particular value, at 15. So that's a t value right there at 15. So what this thing is going to be telling us is how fast the grass is decreasing in that bin because it's decomposing. It's telling us how fast that grass is decomposing on the 15th day. And our units are pounds per day. All right? So knowing all that, let's go ahead. From here, we're going to use our calculator. I want to find A prime of 15. So I've already shown you guys one way to find a derivative, and I would like to show you guys another way of finding a derivative now. So let's go to our calculator, and I'll show you a different way of finding the derivative than the one we've already learned. So we've already got our function. You don't need to press this, but we've already got our function stored up here. All I want to do now is find the derivative at t equals 15. So let me go back to my home screen. I'm going to push second and quit. Now, I want to do the derivative. How do you do the derivative on the home screen? Because we haven't learned that yet. You're going to press Math, and then you're going to scroll down to where it says, let's see, where is it? There it is. It says in deriv. You're going to press that. Now, if you have a TI-84, it's going to look like this. If you have a TI-83, it's going to look a little bit different. Okay? But for now, I'm going to speak to people with a TI-84 because that's the one I recommended you to get. If you have a TI-83, I'll talk to you also. But for a moment, let's start here. So first of all, we're taking the derivative with respect to t on this problem, but my calculator doesn't do t. It only does x. So I'm going to put x here. Then I'm going to put the function in here. I want my a function in there, but once again, my calculator is not going to do a. It's going to have y. So we're going to do that vars thing again. We're going to push vars. We're going to scroll over to y vars. We're going to push 1 and y1. So now I'm taking the derivative of my a function with respect to t, but it looks like I'm taking the derivative of y with respect to x because those are the variables my calculator uses. Finally, at what value am I finding the derivative? Well, I'm finding it at t equals 15. So I'm going to put 15 here. After that, it's as simple as pushing enter, and you've got your answer. So it's negative 0.164 if you round to the thousandths place. Negative 0.164. So I'm going to go ahead and write that down. A prime of 15 is equal to negative 0.164. And we said that that's going to be pounds per day. How did I know that? Because this is a rate of change. And rates of change are always going to be your output units over your input units, pounds per day. Notice that once again it's negative. That means that the amount of grass is decreasing at a rate of 0.164 pounds per day at that exact moment in time when t equals 15. So we're going to do an interpretation now. So this is one of the things we had to do. We had to find the value of a prime of 15. That would be worth 1 point. Just doing that on your calculator. But now we get to do the interpretation. Now when you do an interpretation is going to, you have to include 3 things in your interpretation. Your interpretation should include the input units. Oops. Your answer units, and it should also include the context of the problem. In other words, what's this story problem about? Okay? So I'm just going to write the answer of the interpretation up there, and then I'm going to explain all the pieces of it to you. Okay? So here we go. Here's how you would interpret this particular problem. You would say, the amount of grass in the bin is decreasing at a rate of 0.164 pounds per day when t equals 15 days. So, remember I told you there's 3 things that our interpretation needs to include. First of all, it needs to have the input units. That's the number that we plugged in, and I've got them there. T equals 15 days. This is the rate of change at that point in time. Okay? It also needs to include the answer units. My answer is right here. The answer units are pounds per day. So there's my output units. Finally, we have the context. In other words, what's this story problem about? Well, this story problem is about the amount of grass in a bin. Now, there's one final detail in this interpretation that matters, and it's this word right here. Let me see if I can find a new color. I want to circle it. I'm going to draw a line to that negative there. It's since my rate is negative, that means the amount of grass is decreasing. If I had a positive rate there, then I would say increasing. Okay? So that's how you do an interpretation. Your interpretation here could be worth 1 point or it could be worth 2 points, depending on whether they want to count the units here or not. Now, my guess is they probably would not count the units because they've already counted units up here once, and they're probably not going to count them again. Okay? Usually they'll only give you credit for that once in a word problem. So my guess is that this particular AP question would be worth 2 points as well. So altogether, on parts A and B, we would have had a 4-point AP question here. 2 points for the first one, finding the answer in the units, and 2 points for the last one, finding the answer and the interpretation. All right? And we're going to do a lot of this. And every time we do an interpretation, it's always going to have those same 3 things in it. All right. Let's go ahead and take a look at our next question. All right, so this is FRQ from 2019, question number 6. This is a no calculator question, so you should be answering this without the use of a calculator. In fact, I don't really see how you even could use a calculator on this question for the most part. All right, let's go ahead and get started here. It says we have 3 functions, f, g, and h. Now, this is an interesting word. Differentiable means the derivative exists, but for now, we honestly don't care too much about that, so we'll just hold off on that. Let's just consider that nice filler that we can ignore for now. So I've got 3 functions, f, g, and h, and this is a really interesting fact. They're telling us that g of 2 equals h of 2 equals 4. All right, so what does that mean? Well, let me explain. In parentheses, that's our x value. So our x value is 2, and the answer is 4. That's my y value. So I'm going to go over to and up 4. I'm going to plot that really quick. And here's what I know. I know that at x equals 2, both g and h have the same y value. So I don't know what g and h look like right now, okay? But I'm just going to say, let's just say this is g. I'll call that g. All right? And then let's say that this is h. As you can see, I've got 2 functions, and at x equals 2, they have the same point. They both have the point 2, 4. That's what this means. Okay? So functions f, g, and h are functions where g and h share a common point 2, 4. Now, let's read the rest of it. The rest of it says, this line is tangent to both of the graphs at g. So I'm going to color code this. I'm going to highlight some green. That's a tangent line. There's your slope, there's your x value, there's your y value. So what I'm going to do is I'm going to draw a tangent line. I'm going to make it dotted, though. And it's going to go right through there, so it's grazing both of those functions. So that line right there is tangent to both of those functions at x equals 2. It's tangent to both functions at x equals 2. So as you can see, that green line is grazing both of those functions at that point. All right? So that's the situation we're looking at. Is this what the graph really looks like? Absolutely not. I have no idea what these functions really look like, but this is the best picture I can draw based on the information that they've given me. And for this problem, the picture doesn't really matter to answer the question necessarily. I'm just doing that to help explain what it all means to you. So you actually don't need the picture at all, but it can be helpful to understand things. All right, so let's go ahead and start off with point A, or part A. Part A is asking me to find h prime of 2. What is that asking me to find? That's asking me to find the instantaneous rate of change of h at x equals 2, right? That's what this means. The derivative of h at 2 is the instantaneous rate of change of h at 2. Well, this is a fancy word that can confuse us early on in our calculus studies. What's a less fancy word than instantaneous rate of change? That's the slope of the tangent line, right? So instead of using the fancy word, this is the slope of the tangent line at x equals 2. Well, I've got a tangent line there at x equals 2. It's that green dotted line. It's this one up here. What's the slope of that line? The slope is the one that's in front of the parentheses. So h prime of 2 is 2/3. That's weird, because aren't we used to, when we do this, aren't we used to finding the derivative of our function and then plugging it in to get the answer? Well, we can't do that because I don't even know what h is. So I can't take the derivative of a function that doesn't exist. But what's cool about this question is they're making sure that you understand that the tangent line tells you what the instantaneous rate of change of your function is at that point. So that's what they're testing your knowledge of there. So now, how would this one, how should you write your answer and how would it be graded? You don't have to write everything I just wrote there. All you would really need to write is this. H prime of 2 is equal to 2/3. And I don't see how they would give you anything except for 1 point on here. They're not going to do anything else. Notice that they didn't even ask you to explain it, which is pretty rare. But in this case, they're not asking us to explain, and so it's just a simple, hey, there's the answer, you got it, let's move on. That's a 1 point question. Let's go ahead and take a look at part B now. On part B, they're asking us to do something new. So they say, let A be this new function. So they're giving me a new function. We already have f, g, and h. Now they're throwing a new one at me. They're going to call it the A function. And this A function is the h function multiplied by 3x cubed. So they've given me a new function. They're telling me what that function is. And then they want me to write an expression for a prime of x and a prime of 2. So we've got two things to do in this problem. Let me back up. They've given me a new function, and they're asking me to do two things. I need to find a prime of x. I also need to find a prime of 2. So here we go. Let's find a prime of x. Well, a prime of x, what kind of function is that? That's a product of two functions. How would I find the derivative? I would do the product rule. Okay, so now I'm going to be a little bit confusing here because they gave me an a, and that's going to be different than the a that I use for this. But as you guys know, the product rule is a, b, prime, prime. So let's go ahead and work this out a little bit. The derivative of a is going to be 9x squared, just using the power rule there. And then I'm going to put b right here. Next, I'm going to put a, which is 3x cubed. Next to that, I'm going to put b prime, which is simply going to be h prime. Okay? So right there, I just answered the first question. Find a prime. There it is. You find a prime by simply doing the product rule. But they also want me to find a prime of 2. And all that means is I'm going to go through and plug 2 into this function here. All right, so let's simplify this a little bit. This is 4, and 4 times 9 is 36. I'm going to put a blank there for now. I'm going to come back to the h of 2. Let's do this one now. This is 8, 2 to the third power, times 3 is 24. Now, I already know what h prime of 2 is because I found that up here. H prime of 2 is 2/3. Next, I want to find h of 2. What's h of 2? Well, remember, that's the y value when x equals 2. We can see it on our graph, but we can also see it up here. H of 2 is 4. All right? Now, technically, you don't have to simplify this because we're on an FRQ, and so I would encourage you guys just to stop right there and be done. You could simplify it, but that takes time, and you don't need to go any further. How do you know when you're allowed to stop? As soon as the calculus is over. To simplify this requires no calculus whatsoever. That just requires basic math to simplify things. So that's a good answer. You could simplify it, but it takes time. This is a no calculator question, so you would have to do all that mentally, and it just takes time, and you could get it wrong. Okay, so I would say stop while you're ahead. So how do you know when you can stop? Anytime you have no more calculus to do, and it's just basic math simplification. Okay, so we'll stop for now, and hopefully that's helpful to you guys as you guys are working on your practice problem.